I think it's important to also thank Bristow Helicopters, who very kindly sponsored tonight. I've worked with Bristow several times in the past, and that safety video reminded me of the safety culture at that organization, because it's one of the few companies I've been to where regularly you arrive and as you sit down at the beginning of the meeting, you are given a good safety briefing. And I thought it was a testament to the organization. So thank you, Bristows. Little bit about Dave. Dave Stepanek became Bristow's Executive Vice President and Chief Transformation Officer in March 2021. And in this role, Dave's leading the transformation of Bristow's by introducing the new generation of advanced air mobility aircraft and expanding Bristow's core business in new regions. Dave previously served as Bristow's Executive Vice President, Chief Operating Officer, responsible for Bristow's global operations, supply chain, and IT. Prior to joining Bristow, David held positions within PHI, including president of PHI's energy business and PHI Americas. He has held board positions with Cougar Helicopters and Heli Offshore, the global safety-focused association for the offshore helicopter industry. Dave spent 20 years prior to that at Sikorsky Aircraft in a variety of leadership positions, including technical support, customer service, and commercial sales. And during his time with Sikorsky, Dave sold and delivered the first commercial S-92 model helicopter and booked over $1 billion in commercial helicopter sales. Dave is a veteran of the United States Marine Corps and a fellow of the Royal Aeronautical Society. Please welcome Dave to the stage. Thank you.
Hello, Tim's over there thinking, I don't remember Dave was on the board of Heli Offshore. It was about 3 days, I think, I was on the board of Heli Offshore. I changed roles at one point in time after I was put on there. So I always count that because I'm very proud of all the work that's been done with Heli Offshore. A great organization, and I'll talk a little bit about how I think that can fit into what we're doing with these new vehicles that we're going to be flying around, hopefully, relatively soon. First of all, I thank you, Royal Aeronautical Society, for inviting me here and inviting me back. I've spoken at this conference or this memorial lecture once before. However, this is the first time I'm doing it as a fellow of the Royal Aeronautical Society. I was elected a fellow in 2024. It's one of the proudest achievements of my career, and it sits, the certificate sits proudly in the center point in my office. So it's great to be here, see some old friends and peers and colleagues that we've worked together with, and some new faces. And I'm really delighted that you took the time to come out. I was sitting here wondering if we were going to be able to get some people in the room. I was here last night. Declan Ryan, you may have heard of Ryanair. Declan Ryan was here with one of the founders of another one of their airlines for a nice chat. And he's like, it's like following Mick Jagger. I mean, this place, it was standing room only. He's signing books. He was elected a fellow as well, which I was surprised he wasn't because of all the contributions he's made to aviation. So just delighted to be here. As you've seen, there's some guidebooks on your desk, and this QR code will also lead you to a PDF. We're not going to ask you for any details if you want to, have it on your computer or have it on your phone. However, everybody that's here is an aviation professional or an aviation enthusiast, and I didn't write this for you. It gives you some insight on things of what we're doing and our philosophy. But I wrote it because of the work that I started doing early on with these advanced mobility companies and meeting them, and then meeting people that are going to be investors in these communities or who are going to start out airlines and operations. And I had this overarching fear when I met with them that they don't know anything about what they're doing in terms of how are they going to operate these aircraft. They're brilliant engineers and scientists and entrepreneurs and innovators, and they're building some really, really interesting aircraft. But once it goes into service, they really don't know how to do it. And many of them at first raised their capital on the basis that they were going to design, test and certify, produce, and then operate as an airline. And always talking about, well, it's safety. We're building the best technology in the world. We're going to be safe. And I'll show you a slide here that I carry around with me all the time that's just the beginning of safety. And that's what I express to them. The regulations the stringent regulations that we all have to abide by, specifically in the production of aircraft and the certification of aircraft are much needed, but it's just the beginning of safety. Tim's probably heard me say this before, and maybe Mark has as well, Mark Stevens in the back. Any dummy can buy an airplane. Any dummy can buy an airplane. All of our peers in the industry for Bristow, we all fly the same aircraft. We buy from the same suppliers. We really pull from the same labor pool as well. It's the culture of the business. It's our philosophies. It's our technology are the processes and procedures that we write. That's our software. We're effectively a software company. We buy a technology aircraft and turn it into a tool that hopefully we can get a return on the capital by utilizing our intellectual property and our human resources to do it. So it takes a lot more than just a certified 10 to the minus ninth. It takes a lot more than just really cool technology like fly-by-wire technology, electric propulsion systems, different energy sources. All those things come into play, but there are other things that have to happen to get there. And this slide is going to look very familiar to many of you. Why I'm pointing back there. There we go. Attributed to Dr. Patrick Hudson. I think I first saw this at a Shell conference, actually, or heli offshore, about the importance of technology in getting to zero, but the things that need to occur to get there. So you've got the technology advancements that happen, and this is a continuing loop. And then you have the management systems, your operation procedures, your ground handling procedures, your flight manuals, all the things that you do to manage your supply chain. That's all important. You can buy aircraft and technology. You can somewhat buy the management systems, or you can buy the people that can write them. But the culture is what gets you to zero. And the culture is evolutionary. It takes a lot of time and space to do that. I was at a conference last week in San Francisco, and I put up a map of Bristow's global footprint. And I started talking about things that we've done and how long back it's gone. And we talk about 75 years of Bristow. Alan Bristow started the company in 1955. RAeS started in 1948, which was it's the merger now. We've been in Nigeria for 60 years, Trinidad for 50 years, and the United Kingdom since 1955. That takes evolution to get to the point that we're at. So how are we just going to take this new nascent technology, put it out into the world at rapid pace, and be at zero? And then more thoughts that went into it is, if we don't do something about this now, people are going to die, and the technology is going to get shut down, and we're not going to have the opportunity, at least for our kids and grandkids, to really use this as a potential mass transportation system for the future. In the book, I talk about 20 years at Sikorsky, so I got to meet with Sergei Sikorsky a number of times. He talked a lot about his father. And one of the things that he talked about, and there's also a video of it, about what Igor's vision was for the helicopter. That was always the famous one about search and rescue. An airplane can drop you a basket of goods, and a helicopter can pick you up out of the water and take you somewhere. That's important. But the other one was really a mass transportation system for everyone. There's a video of a guy taking off in a helicopter, like a VS-300, out of his backyard and going off to work and is as a commute. And then he realizes he forgets his lunch, and he flies back, and his wife runs out in a little wicker basket and puts his lunch in there, and he waves and flies away and walks into the office downtown. What's kept us from doing that is complexity and cost of helicopters. They're really cool systems. Takes a lot mechanically to get it to go vertical, but all those things that make you go up and down are really expensive and complex and unreliable and create a lot of vibration and a lot of heat. So all those things that you need to go vertical mechanically with helicopters, with these vehicles, it's eliminated by virtue of distributed electric propulsion systems. So I encourage you to get a chance, if you get a chance to read it. I talk a bit about that in the first part of it. But back to the concerns I had with this system. So I made some observations, some very interesting observations that I'll talk about. And I applied some theses that probably for most people in this room is just like, well, of course. The problem is, our peers all know how to do this. But we're talking about many different companies that have never been in aviation, many investors who have never invested in aviation. because this is green, right? So you got all these people coming in to really apply capital to it. And a lot of capital has been applied to it, more so than our helicopter industry has. Just since 2020, it's about $9–10 billion. And a lot of that's already been wiped out, but a lot of capital coming in. They don't understand. They haven't evolved. They're taking a revolutionary technology and just assuming that it's ready to go because it's the highest technology, it's the highest standard, it's Silicon Valley, we're cool, we know how to do these things. But they haven't applied the evolutionary technologies that we have developed to it, and we need that. And this is one of the reasons that wasn't necessarily the reason we got into it, Bristow, but once we got into it and started talking to the folks and realizing that if we don't assist, if we don't collaborate with this industry, it's going to have a problem. And it didn't have to be us, but it had to be companies like us. We just happened to be the only one that stepped up and did it. I mean, somebody asked me the question earlier today, why aren't my peers in this industry doing it? And my response is, well, one of the things that's really come out of this interesting organization that we merged these two companies is a very strong financial business, a very strong company with bandwidth and capital to look at the future, where our peers are still a little bit struggling. Now they're starting to get better and they're starting to tip their toe into it. So I'm encouraging them to come in. So what we've learned is we've got those 3 observations that we'll discuss. From those 3 observations, I put together 5 theses. It's all in this book, and you'll get more detailed when you read it. But the other thing that's interesting is, you know, a helicopter, rotor, tail rotor, or twin rotor, if you're looking at a Chinook or a CH-46, 3, 5. Now we're talking about, at least for Bristow, there's much more. 7 different architecture types of aircraft: lift plus cruise, tilt rotor, blown lift, hybrid electric, hydrogen electric, battery electric. Those are just some of the different configurations of partners that we've met with and discussed and decided to make arrangements with, because we think these vehicles will have a beginning of a future where we can make them commercial. So we didn't say, you know, battery aircraft are going to have very short range, very limited range, and you're not going to be able to carry a big payload. You're not going to be able to do this. I said, if these aircraft manufacturers can get a performance that we know and can trust, can we build a business around that today? And the answer is yes. And then the technologies will grow. The advancements will happen. It's not just the energy, too. One of the really unique things about these aircraft is that you've removed the turbine engines, you've removed the rotor system, the gearboxes, all the things that just drag you down in weight and aerodynamic drag. So now you've got, you know, ability to create an aircraft that looks futuristic, something you've seen in science fiction. The picture on the cover of the page, that if you look at that aircraft downward, it's an Arctic tern. An Arctic tern is the most efficient bird in the world. It does 2,000 kilometers of migration on a regular basis without really breaking any sweat. The gentleman who designed that really modeled his concepts off that. And he also has some interesting materials that you can utilize now in the airframe architecture and the software processing to make the aircraft more efficient. There's no flight controls mechanically in there in these aircraft. It's all fly by wire. Very interesting flight control laws that are happening. So you can change the hardware, the software, the propulsion systems, the energy to get more efficient is my point here. So it's really interesting, unique. I hear a lot of naysayers about it, and certainly there are limitations like any other aircraft or any other machine. But can you do something with it today that works? And what we've said is, yeah, we can. So we're going to do it. And we're really excited about it. So I'm going to talk to you about my observations, theses, and what we coin as a pragmatic approach to this industry. And I'm going to tell you how we're going to execute it. We're going to do a crawl, walk, and run. And we've got a program set that we're going to be executing in August of this year to start this process, to follow suit on how can we do this pragmatically to ensure safe, efficient, reliable operations. So another thing I tell people is it's one thing to have regulations. Another thing that you as an operator, you have to ensure, regardless of anything else, that you can operate the aircraft safely, efficiently, and reliably. So that's our responsibility. And there's some interesting questions that we need to answer. And one, especially for battery electric aircraft. First of all, because you have the limitations of payload, you're going to maximize the payload likely at every time to be commercially efficient. And you're not burning your energy, which means you're going to take off and land at maximum gross takeoff weight, which is something that doesn't happen in today's aviation world. And you're going to do it multiple times an hour. You have short range, to make it commercial, you're going to be going back and forth, lots of sorties, versus one cycle or two cycles an hour in our current roles. And if you think about commercial aviation, the 121 roll, 1-2 cycles a day. So will the airframe and will the undercarriage be able to take this? Will the batteries be able to be conditioned in a commercial environment versus a test environment? So all these things, we're going to start to answer these questions, and I'll talk a little bit more about as we get to the slides. So observations, I kind of led into this. Some of the manufacturers saying, we're safe. This is the best technology in the world. We know what we're doing. 10 to the minus 9th. We're always going to certify it to the FAA, EASA, ANAC. And what I've learned is that, again, this is just the beginning. We've also got multiple redundant paths, so no single rotor. Many of these vehicles have multiple rotor systems and multiple engines. So where you might see an electric motor, there's generally 2 motors, 2 inverters. It's a dual stack. If you think about a PT6 dual stack session. And I was very concerned that people were being a bit blasé. So we're going to build the aircraft. We're safe. We got a commercial product. We're going to go out and take over the world. The other is this expectation of, I would assume that you may have seen some of the drawings and some of the work that's been done about some of these heliports, hanging off a cliff, beautiful marina, $60-70 million heliports and vertiports, or just picking up your iPhone and hitting the button, and then an aircraft comes and lands in a hotel parking lot or a restaurant parking lot and takes you home. And this started, that number 2 started, I was walking out of a restaurant in Houston with my wife's cousin. We were talking about what we were doing, and she goes, I just can't wait. This is coming in a couple of years. I'll just be able to take an airplane from this restaurant. And I'm thinking, we've got a public perception problem. And then following the news, Volocopter, which was one of the German companies that had a multi-rotor, they were going to do this big spiel in Paris at the Olympics this year. And what happened was the public didn't want it. The mayor of Paris, or the vice mayor of Paris, was vehemently against it, and it just fell apart. So we haven't done our part with the public as well. And it's what I've been doing. Sadly, I only get to really talk to people like this in this room who understand it, is really spreading the word. This mass transportation system, this cartoon of the Jetsons or whatever you have, can happen, but it's not going to happen this year, next year. It's going to happen in the late 2030s or 2040s, because we've got to evolve. We got to take the revolution and evolve it to get it there, so we can do it safely and efficiently. And then again, the general business discussions I get to talk to a lot of investors in this, because they've been filing capital in, and because we've been very upfront about what we're doing. So when a company's thinking about investing in one of these OEMs, I get a call. Hey, how are you going to use it? What's the customer use case in it? How do you think this is going to happen? So I got to meet and talk to a lot of them. And again, it was a very clear message. They don't know what the hell's going on. It's like they're investing in a software system or something to that nature. They're not thinking about it as an aircraft. So we've been processing this and educating them. And that's really why I wrote this. So I'm sorry, there's a lot of words up here. I'm not going to sit there and read them, but these are the 5 theses. And this gets back to whether you're putting in novel technology into the field, or you're putting a new type of aircraft into the market. I've done a few of them, both at Sikorsky, at Bristow, and at PHI. And it's really hard when you put a new aircraft in the system. Aircraft that have been certified, sim types that have been certified, whether that's an S-92, an AW139, an H-160, when you put that aircraft into the commercial market, you're going to learn things and find things that have never occurred in flight tests. When I was at Sikorsky and we certified the S-92, I think we had just under 3,000 flight hours on the 4 flight test vehicles that we used. mean, that's like a year and a half of flight operations in the United States, in any commercial operation for an aircraft. And you're doing it in all these weather conditions and flight tests. You're generally in good, not necessarily always in good weather, but predicted. You know you're going to go into an IFR situation. You know you're going to go into ice or rain or snow. We haven't done that yet here. So if we're going to start, we're going to start simply in a rural environment, very short range, so we can manage the aircraft, manage the supply chain, manage all the conditions. Do it with either a government or a business that understands what's happening, so they're not going to be surprised. So if you think you're going to launch an aircraft in somewhere in the Middle East in a city and move people back and forth to the airport, you can do it, but you're going to have failures, you're going to have problems, you're going to have customer and public perception issues you're going to have to deal with. So do this first, and I'm going to talk about what we're doing, because we are doing thesis number one. And this was the other thing that blew me away. I was speaking at a smart cities conference. So all the major modern cities around the world, Dubai, Paris, Munich, Singapore, all in this room, really smart people. And when we were talking about electric aircraft and what was going to happen, and air taxis came up, or flying cars, which makes me cringe. The gentleman, I think he was from Dubai. He said, "Well, it's just like buying an electric scooter, right?" A quote. And I said, "Wait a second. No, if you're going to put people in an aircraft and charge them for that and fly, you're an airline. And you have to have all the processes and certification requirements that are necessary, and licenses are necessary, all the training, all the processes that go with it. You're an airline." And that was another one of those aha moments. It's like, people just don't understand that because of the perception that's been told to them. These are flying cars. These are taxis. And so I can't believe I actually had to put this in paper and write it, that if you're going to do commercial operations as an air carrier, you're an airline, and you got to have all that thing. Thesis number two. Three, and this gets back to the learnings that we've had, is let's do this first with companies that have done it before, that understand the early stages of the problems. But these companies that are going to do it early, or my thesis is they're going to do it, must be willing to collaborate and share the data of these aircraft, how it's coming along, and how other problems that we're finding. So you got to be part of that. And I'm going to talk a little bit about what I think for this industry, for a heli offshore like organization. And then back to the investment thesis on number four. So you've seen some of the drawings and the plans for cities to build heliports and vertiports, and many of these. Actually, one of my daughters is an architect, and she was working on a program, a heliport in Miami. It's $20 million for this heliport. And if you do the math on the $20 million investment for the vertiport, and you calculate that into the cost and how many flights they're going to do on one of these aircraft, it's a $400 landing fee. And you have 4 seats. It's $100 a person just to land. So that's interesting times. But who's going to? I mean, besides these small investments from some of the governments, who's going to make these major capital investments with a nascent technology that we're not sure is going to work yet? So my argument, my thesis here is, let's use the existing infrastructure, whether it's existing vertiports and heliports, most likely existing aerodromes that aren't heavily utilized, and go with that and start that. So utilize the existing infrastructure that we have, so we don't have to solve problem 500 today. We just got to solve problem 1, get an aircraft certified, 2, get it into operations, 3, prove it, and then scale with those data points that allows the entrepreneurs to make those major investments. And then number 5, this is near and dear to my heart. Health usage data monitoring and flight data monitoring is something that has really taken safety and helicopters specifically to the next level, next stage. It's evolved over a long period of time. Some of it is very painful. Some of the OEMs, some of them, acknowledged it. And here we are. We have a chance again with new aircraft, new technology, day one, having all of the data. All of the data. So it's one thing to have the data. It's another thing is, like, what do you do with it? Okay, if I'm seeing this vibration at X frequency on this location of the aircraft, what do I do? How do I manage it? It's just one. Do I just collect the data and send it off to the OEM? And how do you manage that? I think it's important that companies have that experience and understanding about not just collecting the data appropriately, but utilizing it appropriately and how it can affect the flight operations and safety operations. Okay, pragmatic. 4 stages for our purposes of this is, I mentioned talking about the short range missions. So to couple that, let's do it with cargo. There's a reason behind the cargo. It's not necessarily the obvious one, is that, you know, cargo with a regulator would probably be likely to use. You won't have to deal with customer applications, but frankly, with these vehicles, cargo is really the crown jewel of commercialization, because the cargo networks that you can build with the cost structure around these vehicles is very, very compelling. And you go back to the early days of aviation, the commercial businesses in the 20s and 30s weren't necessarily an airline or a regional mobility. It was flying the mail. It was flying bits of cargo around that made it. It was so compelling that the U.S. government had to enact in 1935 U.S. Airmail Act to break up companies, including United Airlines and Boeing and Sikorsky. They were all one company in the 30s because they were effectively a monopoly. So cargo was really interesting, but it also, it's great business, and it plays into our concepts of, now we can prove and not assume that this emerging technology can be commercialized. And the vehicle you see there on top, that's the Beta Alia CTOL, the Alia 300CX. And I'm happy to say, and you'll see some slides, we're going to be flying this aircraft in Norway starting in August. So it's a production aircraft. It's not a flight test vehicle. It's got a certificate on it, a special airworthiness certificate on it, but it's got it. Next is, now you learn these things. Now let's talk about limited passenger movement. Still thinking about short distances with existing infrastructure. That vehicle right there is Vertical Aerospace. It's built in Bristol. It's a UK company. It's going to get certified hopefully in 2027, 2028 timeframe. The 2 aircraft on top are the only current aircraft that have been piloted all the time, and actually one's gone through transition. Joby and Archer. Joby's flown with pilots, and the rest have yet to do it, other than I think Volocopter on some demos. So tilt rotor, but quite a few multiple rotors. So the forward motors will move on a servo or an actuator, and the back motors are always lifting. And you'll see in my book, I talk about the first one is lift plus cruise. So you actually have fixed lifting motors and a propulsor in the back. It's the most simple design, but not necessarily the most efficient, because you're carrying the motors around, the weight for the motors to both fly in conventional mode and fly in vertical mode. But we like simple first. I think it's important to get rid of all the moving parts as you can. So now we get a little bit more complex. And then regional air mobility. If you think about regional air mobility, again, think about some of the routes that we had in aviation and some of the new airlines that have coming up, really focusing on not the hub and spoke, but city pairs, and maybe spoking out from each city pair for some urban mobility. Regional mobility could displace a lot of land vehicles. It can work very well in areas where you have geographical barriers, such as Scotland, the fjords of Norway and Scandinavia, west coast of the United Kingdom, Australia, Africa with roads. So we like regional mobility, but you can do this effectively with conventional takeoff and landing aircraft, utilizing some form of electric propulsion systems, whether it's a hybrid electric with a small turbine engine. It's got driving a turbo generator and just distributing the electricity out to the motors, whether it's hydrogen or whether it's actually 100% battery. There's a few of those around. This vehicle, again, another UK company, ZeroAvia, is out in the Cotswolds. They've built hydrogen engines. They've done amazing things. I've got to visit them several times in their technology, and they're going to be the GE or the Rolls-Royce of future propulsion, because they're going to scale these up quite efficiently to some larger narrow and wide body aircraft. And then we get to be George Jetson, whether that's 2040 or something. But urban mobility, air taxis, you've proven it out. Investments have occurred. We know how these aircraft are going to work. We can get more complex operations. We've sorted out some of the traffic management systems that we have to do to get automatic traffic management. We've built the heliports. And now we can start to scale this on a big basis. And that gets you to the reason why all this capital is flown in, because that is a massive business. You're talking $1 trillion business potentially by 2040, 2050. And that's attracted all the attention. It's the shiny ball in the thing. And that's why people talk about it all the time. And I want to get there, but this is how some people are going to go straight to it. And I do wish them well, and I hope they're successful. They're going to be limited in geography and scale, but this is how Bristow's going to do it. And we intend to hopefully lead the pack. I talked a bit about Norway, and I kind of teased you that we're going to be taking this aircraft into Norwegian airspace and flying a 100% pure battery electric aircraft. It's going to be flown in conventional takeoff and landing form. So it does not have the lifting motors. The aircraft is 95% compliant with what will be their VTOL, which will get certified in the following year. Pragmatically, let's make sure we can condition the batteries. Let's make sure we can manage the, if we have a thermal runaway, we know how to handle it. Let's make sure we can actually take off and land multiple times. We can fly IFR, VFR, day, night, summer, winter. That's what we're going to do with this program. So we've partnered with the Norwegian Civil Aviation Authority, partnered with EASA and Avinar and Beta Technologies, which is a very interesting company. You should go visit if you have a chance, if you're in Burlington, Vermont. They're really, in my mind, the most pragmatic one of all the industries. They've got a production facility already built. It's private money. It's not, they're not having to deal with the investor community in the world and the quarterly reports that have to go out and making sure they got a great LinkedIn page and all the things that you would do as a public company. So very, very happy with that. We've also, I think about 2 weeks ago, we put out the very first job requirement for commercial electric pilots and in Norway. So the first two of those will be hired outside of the original equipment manufacturers, and we're going to be going through the process of training, which is another thing we got to learn about. So we're going to be training engineers, we're going to be training pilots, we're going to be training ground support people, and we're going to go through this whole process of doing that. We're going to do that again for 6 months in various organizations. First, we're going to fly locally around Stavanger Airport. So Avinar is putting in the charging networks. We're going to fly around. We're going to work with air traffic control. We're going to figure out how any of the issues that we have to deal with. Now, this aircraft has an approach speed of about 120 knots, so it's not going to slow traffic down necessarily, but it's kind of odd to see it in there. The aircraft's flown in from Vermont up to Canada and across the United States, so it's been in the pattern at Pearson Airport. It's been in the pattern in Washington, D.C. It's been the pattern in L.A. It knows how to do it, but we're going to do it and share the information with everyone. And it's just an exciting time. This is really, I believe, going to be a pivotal year for advanced air mobility. And a report will be public that comes out of this. And we're working on the KPIs right now. As a matter of fact, the Norwegian team and some of my team are in Burlington. I'm hopefully going to I'll show you a picture of something after the end of this. They're in Burlington right now, getting ready to approve the aircraft. It's coming off the production line. It's doing flight time. It'll go on a ship to Ireland, come into Shannon. You don't really take it apart. It's just coming on the ship. So they'll fly it from Shannon across the Ireland, across the United Kingdom, and we'll be at the Paris Air Show in June, and then up in Norway, as I mentioned, in August. Bit about the data on the aircraft, what it can do, and these are validated specifications. I mean, one of the first things that we got to do with all these OEMs was ask lots of really tough questions. Kind of felt like I was you, Mark, and Shell at one point in time when I was on the other side of the door. Asked really tough questions about how this aircraft can be operated. What are the real performance numbers? How does it work with reserves? You said it can do this and this. Can it do it all at the same time? You know, that's another tricky question we all do when we mess with the math. The picture here, the gentleman on the left, that's a Bristow employee flying an electric aircraft. His name's Brian Willis. So Brian is one of 370 powered lift licensed pilots in the United States. He flew the V-22 in the Marine Corps. He's flight tested the Bell 609, or the Leonardo 609. Old days. The gentleman next to him is Beta's test pilot, and he's a former F-35 pilot as well. So interesting group. One of the first people in the world, I think, Brian, to fly both the 609, the V-22, and a electric takeoff and landing aircraft. Took me a while to wipe a smile off his face after he finished it. This thing loafs at speed. It's using very little energy. The wing itself has a coefficient of drag 17-1, so it's a very efficient aircraft. We believe that we can carry about a payload of about 1,200 pounds or of 550, 560 kilos. So decent amount of people. The cabin itself, if you look at the cabin, it's like an intermediate twin helicopter in between like an H-135 and an H-145. So it's a sizable piece of a kit. UPS is also going to be one of the primary users. So they've worked on the architecture of the interior to make sure that you can put the right amount of cargo storage and pallets in it as well. Very commercially oriented, very robust aircraft. So that's what we're going to use in Norway. And then just more on how we're going to do the phases. A very stepped approach to it that goes from familiarization flights, city pair, Stavanger, Bergen, over water, day-night operations, IFR, VFR. And then potentially, if the data allows us, we're going to expand into other regions of Norway and then share that information. I've been chatting with Department for Transport here in the United Kingdom and a few others, potentially bringing the aircraft into the United Kingdom post this operation. And it's certainly got some interest, and we're just going to see if we can put things together. The beauty of it is it's a Part 23, it's certified as a Part 23 aircraft. So there's no new things that have to happen. You just have to get your head around. There's no gas. And the other thing that Beta does, which is very interesting, is they build their charging infrastructure. They're building a charging infrastructure for many of the other OEMs as well. The gentleman who started Beta, his name is Kyle Clark. He electrified the Patriot missile systems from diesel to electric, and he worked on he did the high-speed charging for designs for Tesla. So in his part-time, he was a professional hockey player as well. So, he's a really interesting chap for sure. Challenges, always full of challenges. We've got lots of them. I try not to get too hung up on the challenges here, but we've got to sort out the beginning of it. The regulatory framework, which all the regulators are working on right now. In a way, when you go to talk to people, whether they're investors or potential customers, local government, federal government, regulators, you start talking about this technology, it's kind of like pushing on an open door. Everybody wants it. You just got to figure out how to do it, how to align with it. And I think it's going to be important that we continue to share and collaborate this information. I talked about the infrastructure again as a key role here because of the effective billions of dollars that are going to be invested. I mean, think back to early days of aviation. I mean, we all woke up and we got Heathrow, you got Luton, you got City Airport, you got Gatwick, you got Stansted. In the United States, we've got all our major airports and hundreds of thousands, if not regional airports. When we started flying, they weren't around. Same thing with gas stations for cars. So it takes time and an evolution to build that infrastructure up. But most importantly, it takes data to substantiate that investment that's going to be necessary. So that's going to be part of the process. One of the things that I'm really interested in, and I see as a potential gatekeeper, if you will, to advance our mobility are the insurance companies. We have to carry a lot of insurance as an air carrier, especially in the offshore environment. We talk about our limitations of liability. It's a very, very big number. Insurance companies, they like to have data. They like to know what these aircraft do and how they react and there isn't any. So when we went out to insure the operations for Norway, the largest capacity we could get was not even a fifth of what we would normally carry. So we had to come up with some extra insurance just to keep ourselves in a process. And this is with all the discussions that we've been having, expressing to the underwriters and the brokers how we're going to do it. They're all very happy with it. They're keen on it. They just don't have enough data and they don't have enough understanding of how these aircraft are going to be operated. And hopefully, and people ask me like this, well, Bristow, you guys are safe, right? You got this great safety record. You got this heritage of operations. And my response is, safety is just a license to buy insurance. It doesn't guarantee you great insurance. It's just now you can get to the table and actually negotiate with the insurance brokers. So that's another issue we're going to have to deal with. And hopefully these insurance companies will be effective gatekeepers as well, because it doesn't take a lot to get an AOC. I mean, it's hard, but you can do it. There's books, you can hire people, you can get an AOC, but the insurance companies are going to go deeper into the discussion in the culture. And so the regulators are going to be required to provide anybody that ticks all the blocks will get one. Insurance companies can help kind of weed out some of the ones that probably shouldn't be receiving capital or getting aircraft. And the same goes with financing. One of the key to financing an aircraft is what's it worth? What's it worth after you operate it for 4 or 5 years? What's the residual value? What's the secondary or tertiary uses of this aircraft as we finance this asset? And you're financing a helicopter, you're financing a jet. You can think about 20, 30 years of service and have lots of information and data about the values residual, or who can use it, where I can put it. We don't have any of that either. We have no idea what the life of these vehicles are going to be. So we've taken the approach, and not that we're going to have to finance these things straight away, is useful life 7 years, zero value. Can we build a business plan around it? And I think until people start thinking about that, they're going to struggle with some of the cost structures. And then who are the new stakeholders? How are we going to contract with them? Who's going to be the customers? Is this a business to consumer model with an app? Are these logistics companies? Are these energy companies? Are these governments that we're going to utilize these aircraft? So we've got to sort out how you contract with it. One of the most difficult things that we had to do when we were setting this Norwegian operation up was the contract process, not with the Norwegians, but between the aircraft manufacturer and us. So we assumed that we would just lease the aircraft from the OEM for a period of time, be a dry lease, and then we would have a service agreement. But because the fact that this nascent aircraft is a special airworthiness condition on it, the flow of operational control flows through the OEM to us. So they had to be integral to this process. So we had to comply and build a contracting document around FAA requirements, EASA requirements, and Norwegian CA requirements, and our personal requirements to make sure that we managed all the appropriate things that are necessary. So it's going to be really complex. It's not just simple buy aircraft, sign all these really great documents we've had for many, many decades, or lease an aircraft, and then I go out and I find business for it. There's going to be some complexities to go with it in terms of the financing side, and then all the things that are associated with it. And then lastly, I'll talk about no more slides. Thank you. Wait, did we put the picture of the aircraft on here? I'm not sure. There we are. 3 electric, 100% electric battery powered aircraft. That was this morning in Vermont. Hence the Norwegian flag. The Norwegian CAA is there. The one on the back left, closest, well, not in the picture, it looks closest to the H-125, is the aircraft we're going to be taking over to Norway. So I think that's the first time we've seen 3 aircraft of similar type. You see the one in the front is in its vertical configuration. So there'll be 4 lifting props on each of those canards, each with tool motors when it goes into the vertical mode. When you want a conventional aircraft, you can save a lot of weight and payload capabilities by just taking off the front of the canard and getting a simpler aircraft. So that's the Beta Technologies one. But we're partnered. I showed you some pictures of aircraft. You can see in the book. We've partnered with companies that are going to build CTOL, STOL. So Electra.Aero, Dr. John Langford's building an aircraft that can take off inside of a football pitch, utilizing the high speed motors and blown lifts. So think about 100 meters or less. Effectively could hover if it wanted to. We've got tilt rotor with vertical. We've got some other aircraft with lift plus cruise with Embraer Eve, as well as a few others that we're talking with on the conventional side. So we're going to build a network of aircraft, just like we do our fleet today. We operate 12 different helicopters for a variety of reasons because they can execute the missions that we desire. It's going to be the same here. So with that, I'm going to open it up to any questions. Yes, sir.
Good evening. Thank you. Very useful presentation and informative. My question is about me becoming a pilot of this new technology, helicopter driven by electric propulsion. If I complete the existing PPL, let's say in UK, in any airport, and I get my PPL license, will I be able to directly do this, or is there any other, say, conversion or any other course I should do in addition to be a pilot of this helicopter? And also, is there any training school that you have collaborated in UK where I can go and inquire about this?
Okay. The answer is really, I'm going to give this in two parts. There's what you can do is, with the regulatory agencies and other companies that may hire you coming out of a personal pilot's license. And then there's companies like ours that are commercial operations. So you're going to need to get to Bristow or others at least 1,500 hours of flight. We're going to expect, IFR certification, first class medical, probably an ATP. These are the things that we want for our pilots. The part of training is it hasn't been really defined very well. EASA is doing a pretty good job of defining it. FAA is starting to sort it out. Both Flight Safety International and CAE have really jumped into the process. And they've built some simulators for the OEMs and some processes, but there's no schools today that rely specifically for advanced air mobility aircraft. Now, the other part of this, and this might be a little scary for some of our pilots out here, I've had a chance to fly simulators of these aircraft, and if you're coming out of a cockpit of a helicopter, you might struggle a little bit. The first time I sat down in vertical aviation's aircraft, and I got a side control and I've got a thruster. I'm like, okay, pitch. Well, no, there's no pitch axis. What do you mean there's no pitch axis? It's like, I'm going to crash. Try. So I did. I tried. Aircraft landed. The simplification of it, which is another risk, is very, very dramatic for what you're used to. And each of the other problem is each of these OEMs have their own architecture for the control systems, and none of them are alike. Some of them are similar, but not alike. So we're going to have to go through some very rigorous training processes, very rigorous who can get in what seat. It's going to be important. But I think if you start with a PPL and you go out and get some license the traditional way, you're going to have an opportunity. And we're going to need a lot of pilots and a lot of engineers to support the production. Another thing, back to that, I worked at Sikorsky. If we built 50 helicopters one year, we threw a party. Okay, 50 aircraft is going to be 1 month of production for these machines. It's going to look way more like automotive, and it's going to be distributed around the world because not easy to move like you could a traditional carbon burning aircraft. Did I answer your question?
Thank you very much.
Why Norway as the next place?
Have you seen the Norwegian Sovereign Wealth Fund? And so that was kind of a joke, but there's lots of truth to it. They want to do it. The Norwegian Civil Aviation Authority, the gentleman that we were working with, is one of the most entrepreneurial regulators I've ever met in my entire career. It's in their DNA. Their electricity is almost all hydro. They've already adopted EVs. Almost 80% of the vehicles in Norway are electric. I don't know if you've been to Oslo lately, but there's like no noise. Everybody drives around in electric cars. The cranes that they're using to construct things are all electric. And then I mentioned something earlier. I don't know if everybody picked up on it. It's geographical barriers. So Norway's got a great infrastructure, great road infrastructure as well. But they got these fjords in the way. So you have a really, really expensive tunnel where you got these roads that go around the fjords where you could move point to point with a lower cost structure that starts to really ink into what land vehicles would cost if you were moving things by truck. So geographics, a willingness to do it, and an ability to fund some of the program. We're self-funding our bit, but the Norwegians do it. They're buying infrastructure, they're buying batteries. And aviation is really like up in Scotland. It's in the DNA. It's something that they live with every day. So that's why Norway.
Good to hear. And that presumably annoys the Americans as well, because they'd like to be.
I think it's
FAA.
ironic that the capital that's been invested has all been in the United States, mostly. The European capital, some of the companies in Europe have had some failures. There's been some insolvencies recently. But I think it's ironic that we're taking an American product to first fly it commercially in Europe, where we can't get the regulators to really align as well. But so the EASA's done a really good job. The FAA is doing a better job, but the EASA's done a really good job embracing this technology and not writing special conditions, but writing regulations. So that's, yeah.
One at the front here.
Thank you very much for a very professional lecture. Really enjoyable. Did you have any tilt rotor? Did you have any effect from the Boeing Osprey with the problem?
Yes. I'd say that we have, by virtue of we're the launch customer for Leonardo's 609, Bristow is. We're Leonardo's largest commercial customer. And so we've partnered with them on a number of cases. We will be the launch customer for the 609, which is similar technology to the Osprey. And then, of course, my colleague is very close to it, flying it in the Marine Corps for a number of years and being close to some of the incidents and accidents that have occurred. So that program has been delayed over and over again. They just got their TIA. We're encouraged by that. Ever since I came to Bristow in 2020, the 609 was 2 years away. And now it seems to be a little bit less than 2 years away. The issue we're going to have with that aircraft is it's very expensive. It's got a lot of complex mechanical kit. It's unique in its capabilities, so there will be unique opportunities for it commercially, but on a widespread scale, it's going to be challenged by the cost structure. See one in the back there.
Thank you. I've got a few sort of detail questions. So you mentioned the value of the market being $1 trillion. I'd be interested to know how you're basing that. Also, how you see the eventual market to comprise the number of players. So how many companies could end up populating this market. Also, you mentioned 50 vehicles per month. Be interested to know what that is based on. And also, what about redesigning the lower airspace and the urban airspace for this? Because I know in the UK, it's quite a big project to actually redraw the lower airspace to manage these vehicles safely. Any or all of those?
No, I'll do them all.
Thank you.
I'll try to keep them in order. I'll do my best. Trillions easy to remember. So the $1 trillion comes from studies that have been done by the big four firms, McKinsey, BCG, even Forbes has talked about it. They've done the math. That's where they come up with $1 trillion. And that trillion isn't necessarily just associated with the aircraft itself and its operations. It's associated with the infrastructure requirements, real estate, software, the hardware as well, supply chain. It's a big number. When you break it down to operations, it's more like 120 billion for the flight operations side of it. And that's analysis that we've conducted with some of our consulting firms. Oliver Wyman's a good one. And you can break it down even further, like we did, about what could Bristow do? What bit do we have the right to win, or what markets? Remind me what the next question was. Number of players. Yeah, your guess is as good as mine. There's literally hundreds of companies today that are designing and building vehicles. There's dozens that have solutions for air traffic management. There are another half a dozen or so that are serious about ground infrastructure. Some serious players too. Skyports here in the UK is one of them. Atlantic Aviation is another. Urban airports. So there's There's plenty of capital going there because it's a little bit more easy. I should say it's somewhat easier for them to understand the investment because it's a real estate play, and you can add on collateral things to generate revenue like you do at an airport. 50 aircraft was the next one. That comes from stated production goals of the OEMs that we've been working with, and the lead time that it takes to build these vehicles and the way that they've built their production facilities. So I've been to a few production facilities now with a throughput of 300 to 600. It's where you start, 6 to grow to. And it looks a lot like automotive manufacturing. It's not as complex as what we see today in traditional aircraft manufacturing. So it's a shorter build process, allow you to rapidly scale. The issue is going to be like the second and third tier of the supply chain catching up to it. And one of the reasons why a lot of these companies are building their own electric motors or building their own battery packs or building their own flight control computers is because the supply chain doesn't really exist for them today. You can't really just take a Honeywell flight control computer, and you could, but it comes with a penalty of cost and weight. So was there another one? Oh, sorry. That to me is stuff that we need to, I don't know the real answer to that one. I mean, it's going to be different in different locations, but back to the pragmatic approach, if we start flying in rural environments and we could prove out how we're going to do it, then that will allow both the regulators and the companies that are building automated flight control, automated airspace provider, and quite a few of them are doing that. Honeywell's big in it. Embraer is big in it. I mean, Embraer they manage the airspace around Sao Paulo. There's like 1,200 helicopters that are flying around that city. So they know they can do it and then scale it. The question is going to be about getting the regulatory bodies in hand, getting the public to accept the fact that we're going to be flying low and slow. We don't want to end up like Paris. We don't want to end up like Stop the Chop in New York. We've got to work with the public. We can't assume the public is going to accept it because it's a cool technology and we think it's quiet. I had to field the question one time from a person who said, "Oh, it's great that it's, to take off dBs or 60 or whatever. Is there any ultra high frequencies that I need to worry about that's going to affect my dog?" Kudos to the best question in the room, but no, I don't know. We don't know. We'll check that. So we got to get the public involved, and we can do that by virtue of proving it to ourselves, proving it to the regulators to allow us to expand those applications, and then getting the public's acceptance.
Just like one more, maybe two more questions, but from online, Tim.
Yeah, thank you. We've got a couple online. Dave, you mentioned a couple of your manufacturer partners. How does Bristow go about selecting the OEMs that you're going to work with as you develop the strategy?
Yes, well, thanks for that question. Of course, you heard my bio. I was an OEM, so I had kind of a background in both operating aircraft, maintaining aircraft, and buying and selling aircraft, and knowing what it takes to be part of a certification and production of vehicles. So we put together a pretty, I like to say it's sophisticated. Some of it was some just instinct, but what was most important one was who's the team, who's doing this, what are their experience, and do they have the capabilities and the approach to designing and building and producing an aircraft that will appeal to the investment community that allows them to have the capital to do it. There's not too many ways you can carve it up. It's going to be over $1 billion USD or euros. Joby's at 2.6 billion capital raised. Archer's in the 1.6, 1.7 billion. They're burning $400 to $500 million a year in this process, and they're not generating any revenue. So cash is king. Do they have the capability? Not necessarily did they have it at that time, but did, up through our assessment, the ability to do it. And do they have that pragmatic approach? I can't tell you how many people came up to me with a picture of an aircraft that looked really cool in 2022 and saying, this is going to get certified in 2024. This is simple. We know how to do it. We can do it. So I would just immediately dismiss this. It's an 8 to 10 year process is what it is. In many cases longer. I mean, Joby started in 2009 or 10. So it's a long process. I mean, just think about Gulfstream, 777X, H-160 United States as examples of how hard it is to get through the certification process. So, and then we talked about what I talked about earlier is the performance of the aircraft, does it fit into our theses? Our initial thesis was we would support energy companies onshore, kind of a reverse of going offshore. They got to get to the hub, they got to get to the heliport, they got to get off to the heliport. It's got to get there. Can we do this pragmatically? Stuff and people. And that takes about 3 different types of aircraft to get all the ranges and payloads that are necessary. So is it the right aircraft? The other aspect was back to some experiences that I've had. I believed at the time there was going to be a bifurcation of certification, meaning aircraft would get certified in the EASA that we can't use in the US and vice versa for a period of time. So we wanted to be an early adopter, and we have operations in 19 countries and we have licenses in all those regions. So we carved up by having aircraft can be certified in Europe, aircraft can be certified in the United States, aircraft can be certified in Brazil. And as an effective, really only hedge the bets. I was accused many times of saying, you're just buying one from everybody. Well, first of all, I'm not buying them right now. I'm just signing agreements that says, if you do this, we'll buy it. We're using our intellectual property as capital. But it was really well thought out, and the certification side of it was that. So that's effectively how we went through our processes. And the hard part's been, these are all really interesting and cool people. And they're really building interesting and very innovative aircraft. So I had a hard time not saying yes to everyone. I actually hired a guy to help me say no. He was doing the technical analysis. He's a former aircraft manufacturer as well. He's a professor at a university. He teaches advanced air mobility at a university in Singapore. And he was my litmus test. And then I said, okay, we've got a bracket of aircraft. We're going to stick here and run with it. And so it's not me, it's not you, it's me that says no, is really the logic behind that.
But that concludes the Q&A. We're at the end of our time slot, but I'd just like to thank you very much, Dave. I found that really fascinating lecture. I picked up a couple of notes that, first of all, is on the bottom of the slide, didn't really refer to it, but reinforced what I said before of Bristow's attention, the safety culture as your #1 core value. And I think that came through the lecture and the thinking that's going in behind it. And something else I found particularly useful and interesting is often we do hear a lot of positive hype from the manufacturers, of course we would, but it's nice to hear that from an experienced air operator, seeing a good positive outlook for the AAM industry. So that really reinforced. I found it absolutely fascinating, your view of the maturity, how long it's going to take to get there, but how you're planning to go into the market and use the existing infrastructure. Very interesting. So I'd thank you very much for that. And please, can we just give a round of applause? And this is why I wanted to stand here, as we got a small gift for you as thanks for
Thank you very much.
Yeah.
You know, I carry on, right? I'll be carrying
I hope so.
Thank you for having me.